When building your next web app, you're going to have to answer the crucial question of what rendering strategy your app is going to leverage. Will it be handled on the server side, the client side, or maybe a combination of both? But with all of the choices available to us, it sometimes feels like we're drowning in the alphabet soup of acronyms. SSR, CSR, SSG, ISR. What do all of these even mean? And more importantly, what is the best solution for your project? So I invite you to take a journey with me on a brief history of web rendering so we can gain clarity on how we got where we are today and how to choose the best strategy for you. We're going to go back in time to the year 1990. Why 1990? That was around the time that it became common for people to have computers at their home. And if you're a millennial like me or older, you might have been making beautifully pixelated images in Microsoft Paint or playing equally pixelated games like Ski Free. But beyond playing these rudimentary games on our computers, pretty soon we got the internet and we were off surfing the web, visiting early sites like GeoCities. With most of us not even knowing it, we were interacting with what is called a static site, which is the first kind of rendering strategy we're going to take a look at. At their core, static sites were simple web pages consisting of fixed HTML files. While they look a lot different now, static sites are still around and still serve a purpose for simple, unchanging sites, like maybe a local restaurant's website, displaying their menu and location. But of course, they're not ideal for dynamic data where the site needs to be interactive or personalized based on who is using it and how they're using it. As the web quickly evolved, soon we no longer needed to leave the house for simple activities like buying books, because in 1995, Amazon.com was launched. Suddenly, there was over 1 million books to choose from, each with its own web page. Which brings us to the second rendering strategy we're going to look at, the MPA. MPA stands for a multi-page application. And just like it sounds, these apps consist of multiple pages, each accessible by their own URL. Navigating between the site's pages means you're triggering a full page reload. When visiting one of these URLs, that means you're requesting the data for that page from the server, which renders it on the fly. In the context of early Amazon, that meant the server cooked up the page with the relevant book title, image, description, and so on, before then sending it to the client. Because each page is rendered on the server and can have its own metadata, MPAs are very SEO friendly. They offer a clear navigation experience for the user, and you can predictably scale large apps this way. But because every page request involves a round trip to the server and back, this is going to lead to slower performance, navigation delays, and headaches for managing state across all of those page reloads. With all of this in mind, some scenarios where an MPA might be well suited include large e-commerce sites with a wide inventory of products, real estate or job listing sites with different entry points that users might visit in from, or maybe administrative sites that offer a wide range of services. There are many use cases for the MPA. Eventually, in 2001, Wikipedia was launched. This is a perfect example of an MPA. It has a dedicated page for every topic under the sun. This MPA rendering strategy was going strong for bigger sites, and it wasn't until 2004 that we saw Gmail introduce an innovative alternative, the SPA. Gmail showcased the potential for creating dynamic, responsive, and highly interactive web applications through the use of JavaScript to handle UI rendering and client-side app logic. Ajax was used for data fetching in the background, eliminating the need for a full page reload, allowing the user to receive real-time updates and navigate seamlessly around the app, all while maintaining application state within the client. The introduction of the SPA architecture was timely because soon thereafter, in 2008, we saw the introduction of iPhone, Android, and soon their respective app stores, catalyzing the mobile app revolution. These apps feature seamless interactions with fluid animations. Users experienced instant feedback and stateful interactions without huge loading delays. This set a new standard for what users expected from their digital experiences. So, it's not a coincidence that major platforms soon after, such as Twitter, transitioned from an MPA to an SPA, enhancing user experience with a dynamic interface. Taking a closer look at how an SPA functions, it's key to understand what is meant by single page. Typically, especially within a Vue.js application, we're referring to the index.html file, which is the app's entry point, inside of which everything is loaded and rendered. Instead of doing full page reloads, SPAs enable client-side navigation. This approach maintains the native-like experience that mobile apps had gotten users used to. But SPAs aren't perfect, they do have some downsides. Because browsers have to download the entire bundle before rendering all the components, This can result in damage to performance scores, like CLS and LCP, especially on slower connections or less powerful devices. And because everything is rendered on the client, your pages can't be crawled and indexed, resulting in poor SEO and no social sharing content previews. Understanding their pros and cons, SPAs are particularly well suited for web applications that need a dynamic, interactive experience with instant feedback. These include dashboards, analytics tools, certain kinds of social networks, and interactive productivity apps. As the use cases for SPAs expanded, we saw the introduction of SPA frameworks such as AngularJS, which Google released in 2010, offering a library that made it easier for developers to create and manage dynamic SPAs without all of the complexity. This was followed up by Facebook in 2013 with its release of React. Pretty soon, we saw major platforms like Instagram, Airbnb, and Netflix adopt the React library. And over a decade ago, in February of 2014, we saw Evan You release Vue.js, which was rapidly adopted by major sites like Alibaba, Xiaomi, and later, GitLab. With the increasing demand for fast-loading, SEO-optimized sites, along with a more efficient developer experience for building complex apps, this all spurred the development of meta frameworks like Next for React and Nuxt for Vue. These meta frameworks supplement their underlying frameworks by automating away common tasks and boilerplate and providing built-in performance optimizations. Now let's take a deeper look into the rendering modes within Nuxt.js. While it's possible to use Nuxt to create an SPA while gaining some additional benefits, a common reason developers choose Nuxt is to overcome challenges related to SEO and performance optimizations by leveraging its built-in support for alternative rendering modes such as SSR or server-side rendering. With SSR, the browser requests the web page from the server, which builds the page, including fetching any required data, and then sends that fully rendered HTML back to the browser, along with a JavaScript bundle that contains any necessary logic. Once it's received by the client, hydration occurs. This means JavaScript is executed, event handlers are attached, and the page becomes fully interactive. Button clicks, form submissions, and page transitions start working. In essence, hydration is the step that transforms the server-rendered static page into a dynamic application in the browser. This is why we call this a universal app, also known as an isomorphic app, because it exists both on the client and the server. Because you can move dependencies and data fetching to the server, you can achieve a faster initial page load, improve performance scores, and an overall smaller client-side JavaScript bundle size. And crucially, search engines can effectively crawl and index your pages, improving the SEO of your site, while also making social sharing previews possible. SSR shines in scenarios where real-time content is key. For example, a breaking news site using SSR is guaranteed to serve the latest published news to their visitors. A live sports site can deliver scores nearly instantaneously, ensuring the action on the screen matches the action on the field. And for better or worse, online shopping these days is not just about anonymously browsing products anymore. SSR can tailor the shopping experience to each visitor by quickly generating pages that reflect preferences, search history, and behaviors. But what if your site doesn't need to be highly personalized or interactive? In these cases, meta frameworks like Nuxt allow us to achieve static site generation. As it sounds, static site generation allows us to pre-build all of the pages of a website into static HTML files through a command like Nuxt generate. These pre-rendered pages can then be deployed to any web server or hosting service capable of serving static assets, including CDNs, to benefit from their global distribution and performance optimizations, so that at request time, these pre-built files are sent directly to the browser without any need for real-time page generation, ensuring fast load times and improved performance. However, the main drawback to this approach with SSG is that if you have a large site with a lot of pages, it's going to take you a long time to generate all those pages at build time. So if you did have a large news site, imagine waiting for all of your pages to generate before you could deploy that breaking news. It just wouldn't work for your use case. So SSG is best suited for very static sites, including portfolios, landing pages, and documentation sites or blogs where content does not need to change often. Looking at these different rendering modes, you might be thinking, well, within my app, some pages would work really well as an SPA, but some would work well as SSR or SSG. Fortunately, with Nuxt, we can achieve a hybrid approach and use a mix and match of different rendering modes. With these hybrid rendering modes, each may have a different caching rule per route. One such hybrid caching mode is SWR, or Stale While Revalidate. This is somewhat like SSG on demand. When a user visits a page for the first time, that page is built and then sent back, while simultaneously being stored in the cache. Importantly, there are two different ways to achieve SWR with Nuxt, with or without TTL, or time to live, set. Without a TTL, or time to live set, Nuxt will save the API response that was used for generating the first version of the page. Then, on the next page visit, that cached HTML is what is sent back. Only the API is called on these subsequent requests. When a change is detected during a request, the server returns the stale response and generates new HTML in the background, which will then be served for the next request. Alternatively, with the TTL set, we're essentially setting a countdown timer. That timer is going to reset the cache after a set duration. Once that timer's duration is up, the cache is going to be reset. The page is then regenerated and cached in the background. Within Nuxt 3, we also have the hybrid rendering mode of ISR, or Incremental Static Regeneration. You may also see this as ISG, or Incremental Static Generation. It's really the same concept. In Nuxt, though, you're going to look at ISR specifically for that acronym. ISR's rendering and caching behavior is very similar to SWR, except that we are able to add the response to a CDN cache. With no TTL set, the content persists until the next deployment inside the CDN. However, it's important to note that at the time of this recording, this ISR behavior only works on the platforms that support it. Currently, that is Vercel and Netlify. With the TTL set, the response is cached on a CDN for the set duration and then regenerated in the background at that interval, and then replaces the cache. Now that we have an idea of how these rendering strategies work, let's look at how we might set up a route rule-based rendering setup for a Nuxt app. Let's say we want our homepage to be statically generated and our admin dashboard to function as an SPA, while our blog utilizes ISR. Within our Nuxt config file, we can set up route rules to achieve this, where pre-render true sets up our homepage to be pre-rendered at build time, SSR false tells our dashboard to render only client-side, and ISR 3600 informs the page to be generated on demand and regenerated every hour. Of course, that 3600 can be changed based on the duration that you want to set. It's also important to note here that this hybrid approach is not going to be available for you if you build your entire project with a command like Nuxt generate, which builds your project as an SSG. Instead, if you want some pages to be SSG and others not, just do it in this config file. Don't build with Nuxt generate as an SSG. In order to have a more comprehensive, contextualized understanding of rendering, how do these Nuxt rendering strategies compare to other frameworks? If we look at Nuxt.js, we'll see that it has essentially the same rendering modes, although the implementation details are going to vary slightly. But what you're seeing on the page here is really limited to the pages router of Nuxt.js. With Nuxt 13, there was the release of the app router. These rendering options are essentially still possible, but are simplified conceptually into server components and client components. Adding Vue's client to the top of a component file puts it into a client-only or SPA mode, whereas server components are the default, and they will have their rendering strategy automatically chosen based upon functions in that file, like get server-side props for real-time data or get static props for pre-built pages. You can leverage client components for the parts of your UI that need to be interactive, or which rely on things like state, lifecycle hooks, browser APIs, or React class components. The remaining components can all be server components. With React's suspense component, pages can be broken into chunks that are progressively sent from the server to the client, effectively streaming the UI from the server as it's available, allowing the user to interact with parts of the page before it's completely loaded. This component-based rendering strategy is similar to a newer framework that came onto the scene in 2021 called Astro. While it's technically a framework, I'm calling it a neo-framework because of its unique ability to be composed with a combination of any of the other major modern JavaScript frameworks. Astro has helped popularize the idea of islands architecture, where only certain sections of the app receive JavaScript hydration. As I mentioned, you can compose an Astro app with components from various major frameworks. and then use client directives to control how these components are hydrated on the page. But Astro is not the only framework leveraging this islands architecture approach, because Nuxt provides the Nuxt island component, which at the time of this recording is still experimental. The islands in this context are inverted. In the Nuxt context, the island is the non-interactive component, which to me makes sense because if you don't want the component to be hydrated, it's not getting wet, it's staying dry, it's sandy, it is on land, so therefore it is the island. And then anything around it is hydrated, so therefore it is the ocean, it's the water. It receives that hydration. But that's just my take. So when we really pull back and look at the state of web rendering today, what are the key takeaways? As we're seeing not just within Nuxt, but in its alternatives and the general web rendering space, developers are focused on fine-tuned hydration, not hydrating things unnecessarily, and therefore shipping less JavaScript to the client, leading to faster loading, more performant, user-friendly, and SEO-friendly applications. So now that we're inundated with knowledge about rendering strategies, how do you choose the best one for you? Based on what we've covered so far, you probably have an idea of what direction to move into, but let's make it even easier for you. A decent approach about reaching clarity about your rendering strategy is to ask yourself a series of questions. First, is SEO important? If yes, then you don't want an SPA. Ask yourself, how often does my app need to update? If it's minute by minute, you likely don't want an SSG, SWR, or ISR. If it's hourly, an SSG would also not be very efficient. Ask yourself, how do you want to host your app? If you have static hosting in mind, you'll want to avoid SSR, SWR, and ISR. And finally, is first load performance important? If so, you might want to avoid SSR and SPAs. If we look at our use case with the Vue Mastery platform, we are a content site where SEO is important, updates are made weekly, static hosting is preferable, and first load performance is definitely important. So therefore, an SSG would be a good fit for us. Alternatively, you could argue for a hybrid approach, where all of our content is statically generated as SSG or otherwise, and then the user dashboard is SPA, and so on. And that brings us to the end of the course. To build some Nuxt applications and play with different rendering modes, check out our playlist full of Nuxt courses to deepen your skills.